Hi there, and welcome to the video in which I'm going to talk about implementing Cisco CSR 1000V in the AWS environment. My name is Sumit. You can reach out to me at below email IDs, or you can visit the website uptimebits.com.au to get the full list of courses that we're offering. On YouTube, don't forget to like, share, and subscribe, and press the bell icon so that you don't miss any update from us. Now, for today's scenario, we've got internet on the right-hand side, and we've got AWS on the left-hand side. So this is internet and this is the AWS cloud. Within the AWS cloud, we've got a VPC. And in this VPC, we've got two subnets. One is outside and one is inside. And we've got a Cisco CSR 1000V router over here on which we'll be doing the configuration. Now let's go ahead and start the configuration. Okay, so here we have the VPC. I'll just go to the VPC tab. And as you can see that we've got one VPC. The CIDR for this one is 10.0.0.0/16. And we've got two subnets, as I just advised you. It's 10.0.1.0/24 and 10.0.0/24. So one is inside, one is outside. Now I'll go ahead and launch a router. So go to launch instance. And here we have to do a search in the Amazon Marketplace. So here just go ahead and type 1000V, press enter, 5 results. The one that we're going to use for this particular scenario is this one, the Transit Network VPC, BYOL. So this is the image that we're going to use. I'll select this one. It will take some time to load. Okay, so I'll continue. Now, by default, it will take C4 large instance. I'll go ahead and use that. Now I'm in VPC test, subnet, outside. And for the outside subnet, I'll use 10.0.0.10. I'll add one more Ethernet interface and ensure that it's an inside subnet, 10.0.0.1.10. I'll go click on next. I'll use the default for storage, no tags needed. And for the security group, I'll use a pre-existing security group in which I've got rules that allow all TCP and UDP transmission. This is not very secure, so use the one that is best for your scenario. Now I'll launch this instance, key pair. I'll choose an existing one. And now it's launching. Sometimes throws an error launching. So let's just go ahead and check whether we have it or not. So if I click here, I can see that yes, it's running. So not sure why threw the error. But anyways, I'll just name it RTR1 and just validate that it has all what we need. So it's got 2 private IPs. Should have 2 Ethernet interfaces, and the security group is also correct. So the first thing that I would recommend here is that you need to note down a few things. So on the ETH0, just note down this interface ENI or interface ID. So I copied it. I'll paste it in the notepad. And similarly for ETH1. Now, one important thing that we should be doing right away as soon as we use a Cisco router is that go to the network interfaces and allow disable the change source destination check. This is a router, so it should behave like a router, not like a host. And we should be disabling this. If you don't disable this, then definitely we'll have issues. Now, let's go ahead and try to log into this router. So I'll go ahead and log in. But before that, of course, it'll need a public IP. So let's go to the Elastic IPs. So let me go there. Now, since this device has got two interfaces, we cannot allow we cannot assign an Elastic IP right away during the launch. So I'll create an Elastic IP, and I'll also associate this one to a network interface. Now this is where we'll be needing it. This one is our outside interface, ETH0. Use that, and the private IP address. The private IP address. Okay, so that's taken care of. Now it's still initializing. Let's see if we can log into this router. Let's open the command prompt, and I'll use the IP address. I'll use the public IP address to log in. Now here, I would also copy this IP address over here. Control C and Control V. So this is the IP that we'll be using to get into this router. SSH-L EC2-user-I key_pair.pem, and this is the IP. I'm able to log into the router. I'll verify the IP addresses. Show IP int brief. I've got an IP address already configured. The next one, the other one, I'll have to configure. Interface G2 manually 10.0.1.10. No shut. Okay. So this router has got two IP addresses now. This is showing down, down. We'll see what's the issue a little later. So this router is now up. We are able to log into it. Now we need a machine that will be using this router to go out to the internet. So let's go ahead and create one more instance. And this time we'll take a simple one, a free tier image. If it gets hung, then just refresh the browser. It should come up. So I'll use this one, the first one on the top, and I'll use the free tier. Configure instance details. Now VPC will remain same, but it will go into the inside subnet. Auto assign public IP. Let's do that. And this IP address we should give as per our diagram. I'll do next. I'll change the security group, and I'll use the same one that I'm using for the router. It's got quite good rules that I'll be needing. And then I'll do launch. Okay, so I've launched the instance. Now let's see what all instance I have. Again, if it's slow, just refresh the browser. So I've got a router, which is now in running state, and I've got a host, which is also in the running state. I'll name it as host one. Now let's go ahead and log into this host and enable local login to it. So for doing that, in the meantime, I just validated when the router was fully running. This interface, the second interface, all automatically came up. If you can see, it was down earlier. It came up now. So now I'll log into the host. Now for logging into the host, I just need to change the IP addresses that I'll be using to get into this host. Okay, there's one reason why I'm not able to log into it, and that's because of the routing table. So here for this host, I've got the subnet. This host is in this subnet, and on this subnet, this is the route table. And you can see that for everything, it's not going towards the internet gateway, it's going to the ENI, which is our router's interface. So I'll go ahead and edit that. Routes, edit routes. I'll remove it and I'll say internet gateway. This is a black hole because the interface which was there has been deleted. So it was from the previous configuration. That's why it's showing black hole over here. So instead of pointing it to a router's interface, I'm pointing it to the internet gateway, and I'll do a save routes. So now this system should be accessible through the internet. Yes. So now I'm to the Linux host. Now I'll have to run few commands so that I can enable a local user onto this. And those commands are here. So I'll have to add a new user. Actually, I don't want to use the SH keys to get into this box for my lab. So I'll create a user and then I'll give a password to that user. And I'll also have to enable password authentication. So for that, I'll have to edit the SSD underscore config file. I'll go down and I'll have to uncomment the password authentication. Oh, I'll have to just edit it and say yes here. Escape :WQ. This is how we edit the Linux, a file in Linux using VI editor. After this, I'll restart the SSD service. Now I should be able to log into this particular machine without using a temp file. So let's do that. So here I'm able to log in. If I do ping to a DNS, which is on public IP, I'll be able to do that. If I do a trace, I'll be able to see what path it's taking. So as you can see that it's going out through AWS. Okay, so going back to the scenario, what we want now, as of now, how it's working is that, I'll just take a pen. As of now, from internet, through this internet gateway, we are able to access this instance using the public IP. What we want is that this instance, and this instance is also going out via this route. What we want is that it should go via the router. So it should go via this route to the internet. So for doing that, first of all, we'll have to change the routing table and point all the routes of this inside subnet to this interface on the router. So for that, I'll have to put the routing table back again to where it was. And then we'll also have to set up a NAT on this router so that all the IPs which are in this particular subnet, the inside subnet, can be NATed to this interface's IP, this gig one's IP, and then it will go to the internet. So let's go ahead and do that. Okay. Now I'll go ahead and change the route back to where it was. Instead of internet gateway, I'll use routers interface. Now I'll pick up the routers interface, which I noted here. So E0 is for facing internet. This is the one which is our inside interface, you can say. So I'll use this and I'll save routes. Now I need to go ahead and configure static NAT onto the router for it to work. So for this will time out because we've lost connection because I edited the routing table. We'll give it a few seconds. Okay, so let's go ahead and log into the router. IP address router is this one. So I'll have to use this one, ending with .32. So here I'm in the router. Now I'm very thorough with NATing, but if you are not very sure about Cisco's NAT configuration, I recommend referring to the online documentation of Cisco or refer to your CCNA books. So here I'm configuring NAT. So IP. So on the interface gig one, I'll say IP NAT out, interface gig two, IP NAT inside, and then I'll create an access list. IP access list standard 10 permit. I'll say 10.0.1.0. This is my inside subnet that I'm permitting. This will be used to match whatever we want to NAT through this router. After doing that, the command is IP NAT inside source list 10, and we want to NAT it to gigabit Ethernet interface, gigabit Ethernet 1, and we'll do overload just to ensure the PAT is taking place. Okay, so this has been done. Now I'll try to log into this host from this router. So SSH-L Cisco, and I'll use the private IP of this host 10.0.1.100. Okay, so now within the network, I'm able to get into this host. I'll just go and refer to the diagram so that you are clear what I'm trying to do. Okay, so what I did was I configured NAT on this router. So this one is IP NAT outside, this one is IP NAT inside, and then there's a NAT entry, IP NAT inside source. I also created an ACL. That ACL was 10, and it is matching this subnet, which is my inside subnet. Now what I'm doing is that since these are directly connected interfaces, these two, from this router, I did a SSH to this directly. And now I'm into this instance, the host one instance. Okay, if you're not able to get it, just pause the screen or just re-listen to whatever I said. I think it should be clear. Okay, now going back. to the command prompt. So here I'm in this box, the host, and now I'll see if I can ping 4.2.2.2 via the router. It's not pinging. And I'll try to do a trace to see what's the issue. As we can see, it's going correctly to our router's interface. The first hop is correct. So probably it's the NAT has got some issues. So let's go ahead and see what the issue is. I'm on the router. Show run IP NAT inside source. This looks correct. Show run interface G1, IP NAT outside, G2, IP NAT inside. So NAT entry looks correct to me. Let's verify the ACL. Access 10.0.1.0. This also looks correct to me. So this system should be able to go to the internet. What I can do is see whether there is NAT happening or not. So I can see there are quite a few NAT entries which are there. So my host 10.0.1.100 is trying to go to this. And so there's a lot of NAT entry. That means that it's able to go there. It's just that due to some rules, we are not able to see it. So let's go ahead and change some rules, but let's go ahead and see if we can do something else to validate this. Okay, let me get a public IP of, let's say, Google. So here I'm trying to get a public IP of Google. And from this host, I'll try to do to this IP on port 80. Okay, so Cisco is not allowed to do this. I'll have to log in via the key to do this. But anyways, let me see if there is any other way that I can validate this. Trace. Let's see if the trace gets completed or not. If the trace gets completed, we'll be sure that yes, it's going fine. So yeah, the trace getting completed. We can also see the NAT entries on the router. If I go ahead and quickly see, show IP NAT translations. And we can also see that the first hop that this host is taking to reach the internet is our router's interface 10.0.1.10. We are absolutely sure that our scenario is working fine. So this host now is using this as the first hop, and then the packet is getting netted and then sent out via the internet gateway to the internet. So this is how we go ahead and configure the Cisco CSR 1000V in the AWS environment. Thanks for watching.